World Geography Chapter 1 Concepts The Universe and Solar System. The universe is incomprehensibly large in size and dimension. It contains everything that exists, from the tiniest subatomic particles to galactic superclusters. The largest structure known. Nobody knows how big the universe is, but astronomers estimate that it contains about 100 billion galaxies, each comprising an average of 100 billion of stars. Expanding universe. The evolutionary theory of the universe conforms to the principle that the distribution of galaxies is uniform in all directions throughout the space. Under this concept, to an observer from any galaxy, the average composition of the universe would appear the same. Galaxies. A galaxy is a huge mass of stars, nebulae, and interstellar materials. The smallest galaxies contains about 1 lakh stars, while the largest contains up to 3,000 billion stars. Galaxies are the major building blocks of the universe. A galaxy is a gaunt galaxy is a giant family of billions of stars, and it is held together by its own gravitational fields. The universe is organized into galaxies of stars together with gas and dust. From the billions of galaxies, two basic types have been identified. First one is regular galaxies and irregular galaxies. In regular galaxies, the regular galaxies are disc-shaped galaxies, or elliptical galaxies, or spherical-shaped galaxies. So regular galaxies may be either spherical or elliptical in shape. Spiral galaxies, the Milky Way and the Great Galaxy in Andromeda are examples of large spherical galaxies. Disc-shaped with greater concentration galaxies have curved spherical arms. About 25% of all galaxies are covered spherical arms. Spiral galaxies are well supplied with the interstellar gas in which new bright young stars form. As the rotating spiral galaxies around the galaxies, it encompasses gas and dust, triggering the formation of bright young stars in its arms. Elliptical galaxies, the most abundant are probably the elliptical galaxies. These are generally smaller than the spiral galaxies. They are generally symmetrical or spheroidal shapes with no obvious structure. Most of their member stars are very old and no new star forming in them. Some of them are so small that the term dwarf has applied. The largest known elliptical galaxy is 2,000 light years in diameter. The biggest and the brightest galaxies in the universe are elliptical, with masses of 10 to 13 times that of our sun. About 2/3 of all galaxies are elliptical. Next is regular galaxies. Irregular galaxies comprise about one-tenth of the galaxies and come in many subclasses. The stars of the irregular galaxies are generally very old. Some of them have a mixture of old and new stars. The Milky Way and other spherical galaxies consist of a population of old stars in the center and the youngest star located in the arms. Our galaxies. Our galaxy has a shape of a flat disk with a central bulge. Its diameter is about 100,000 light years in the nucleus. The thickness reaches 10,000 light years, whereas in the disk it is 500 to 2,000 light years thick. Nebulae. A nebula is a cloud of the dust and gas inside a galaxy. Nebulae become visible if the gas glows or if the cloud reflects straight or obscures light from distinct objects. The processes of evolution of star and stars. Dwarfs. White dwarfs are extremely small stars with density greater than that of any known terrestrial materials. It is believed that white dwarfs were once normal-sized stars whose internal heat energy was able to keep these gaseous masses shrinking under their own gravitational force. Eventually, however, these stars depleted their nuclear fuel and collapsed to the planetary size. Although some white dwarfs are not larger than the Earth, they are nearly as massive as the Sun. Thus, their densities may be million times that of water. A spoonful of such matter would several tons, allowing atoms to take up less space. The matter in this state is called degenerate matter. Once a star has concentrated into a white dwarf, it is without a source of energy and can only become cooler and dimmer. Although none of have cited the terminal stage of white dwarf must have small cold non-luminous body called a black dwarf, black hole neutron star. The small white dwarfs are the most massive and the large one are the least massive. The reason for this is that a more massive star, because of its greater gravitational force, is able to squeeze itself into a smaller, more densely packed object than a less massive star. Thus, the smaller white dwarfs were produced from the collapse of the large and more massive stars. If the Earth were to collapse to the density of the white dwarf neutron stars, it would have a diameter equivalent to the length of a football field.